This is my Craftsman bandsaw. It's 12 inch, I think. I've taken it apart and taken the single speed AC motor out of it. I want to put a treadmill motor with variable speed in it. What I want to do is figure out how many feet per minute the blade is running. So what I've done, this thing runs too fast to cut metal. I want to cut metal on it. I put this is an 8-inch pulley on the top. These guys right here, this is 13 inches across here, which means that each revolution is about 40 inches. So if I want to measure what my feet per minute is, I need to count the revolutions and get pretty close to what that is. This right here is a little proximity sensor. It's a tachometer. I've machined a little aluminum barrel and screwed it with a hole in it to the case of the bandsaw. And curiously, since there are 6 spokes in that wheel, I'm going to put a magnet on every 3rd spoke, which means that the tachometer will be reading about 3 times what the actual speed of the wheel is, but with each revolution of the wheel being about 3 feet, then the tachometer will pretty close give me how many feet per minute the blade is actually moving. It's, well, if you multiply 13 times 3.14, it comes out to about 40 inches. So this goes around 40 inches. So with this triggering 3 times, it'll be measuring approximately 36 inches. So the tachometer will tell me that it's running about 36 inches when it's actually running 40 inches. So I can in my head kind of convert that. So what is that? Some percentage. So anyway, I've got this thing taken apart. I am going to put a treadmill motor down here on this, where the AC motor mounted before, I think. I'm trying to. So that I can run this thing. And I've got a 3-way plug right here. One plug will go to run the motor. And I've got a variable speed controller like I put on my lathe to run that. The other one will run the display for the tachometer, which I'll probably mount it up here somewhere, maybe on the side. I'm not sure which yet. The 3rd plug on it, I think, is going to run a vacuum. I'll get a little shop vac to connect up to this port right here. Because boy, this thing really stacks up the debris. I use that big shop vac right here and pretty much fill it up with the crap that I vacuumed out of this thing just opening it up. So that's my plan right now. Now, what I've done, I have made some aluminum plates. In here is my plate that I'm going to mount the motor and everything to. There's a pulley on pillow bearings. Let's see, let me take this thing apart right quick. This is made out of 1, 2, 3, 4 plates. There will be another 1/2-inch plate on the back when I mount it actually to the saw. But this right here was actually a machined 3/8 plate that I acquired somewhere along the way. I don't know where. I don't remember. These right here were made out of just mill spec aluminum, 6061. I put them in my milling machine with a fly cutter to plane them off on both sides to flatten it, because they had pretty good bow in them. They were pretty ugly. So these 4 holes and these 4 holes are drilled and tapped for 1/4 20. This fits on top of here like that, and it gets sandwiched. This fits here. Now these holes right here, these are just relief holes for the 3/8 inch bolts that'll be holding the pillow blocks down. This goes here. This one goes there. These 4 bolt holes right here, these are drilled and tapped 5/16, and they will go to these guys. This is the treadmill motor that came off that treadmill, and these two slots right here will adjust it up and down so I can adjust tension on the belt. Also, the pillow blocks have slots on them so they can be adjusted. They will fit like that, and then this one goes in on this side. Once there's a pulley, there's a V-bolt pulley coming in here that will attach to the pulley that's on the saw now, and then this guy will slide over this shaft and then bolt down onto here with these two 3/8 16 threaded holes. So this is a J pulley that actually came off the treadmill that this motor came off of. This is a J pulley too. I think this is like a 1.6 inch diameter. I don't remember what this is. It's like 4.5, something like that. So I get a gear reduction from here to here driving this, and this little 1.5 inch pulley will be driving that 8 inch pulley that's on the saw. And this motor right here spins up pretty fast. It'll spin up to like 3,800 RPM. So I think I can get plenty of speed out of it. I wanted the double reduction so I could get the motor to run a little faster, so I wouldn't lose the torque cutting things like steel. I wanted the motor to, you know, be spinning fast enough so it wouldn't load up and bind. This is a little clutch I had considered putting on there, but I decided not to. I'm just going to run them direct. I may change my mind later, but this is not that one, this one. This is a little plate of 1/2 inch steel that will be mounted to the back. I'm going to mount it and slide it up and down like this, because when it mounts to the saw, I want this whole plate to be able to move up and down on the saw. There's slots in the back of the saw mounting bracket that actually let it go sideways, so that gives me sideways on the saw and up and down on this bracket right here. I'll be using 3/8 T-slot nuts. I think I'm going to cut slots in this. It'll actually go all the way through all three of these pieces, and put T-slot nuts on the top, and then run 5/16 bolts from the plate on the saw through those so I can adjust it. But that's my plan. I hooked this thing up last night and spun it, and it spun pretty quick. I'm pretty happy with it right now. See, this right here goes through this, and threads into this one on the bottom. See that one down there is threaded. I don't know if you can see it or not, but they are threaded. I think you can see that one okay. Okay, this is it all together, well sorted together. I'm still waiting on a pulley that I'll mount in here that'll connect up to the bandsaw blade. But this is that handy dandy little variable speed controller that people are using now to run these treadmill motors. Variable speed. This is actually the belt that came off the treadmill. This motor and that pulley right there were together on the treadmill. Now I had to machine on the lathe a hub to fit inside this thing, and it's pressed in. This is a 1/2 inch shaft. This is stainless steel. I put set screws from both sides, and there's a flat. I don't know if you can see it. Might be able to. There's a flat machined. There it is on there for the set screws to fit in. It's on both sides. So my fear is that this thing might slip off this hub. It's a pretty snug fit, but if it doesn't, I mean, if anything happens, anything weird, I do have a little place right here I can put a screw in there to attach this to this. Then I'll have to balance it, I'm sure. But the belt is not real tight, but it does work. You can see how this all goes together. Oh, the reason, I don't know if you can see under there or not, that screw hanging down right inside there. The reason I cut those holes in the bottom plate was because I wanted to use hardware that I already had in my screw bin without having to go to Lowe's and buying their ridiculously overpriced fasteners to get one exactly the right length. So I think those are 1 3/4 and maybe 2 inch. I think they're 1 3/4 inch long. They're 3/8, 16ths, and there's 4 of them. So if I take this, I'm not sure where it's going to start. There we go. There we go. Yeah, that belt's pretty sloppy on there. I'm going to tighten that up, which I can do. I don't think I snug those down when I put the motor on. Just left them loose. Watch rattling. The next thing is to get this disassembled again so I can put the pulley on this 1/2 inch shaft right about here that'll then go up to the bandsaw blade with that 8 inch pulley that's on it. So here we've got to cut a slot here and a slot here for the 3/8 T-bolts, and this is going to bolt against the mounting plate on the back of the bandsaw. I'll show that once I get it done. I'm making a change in my approach. I was putting a 1/2 inch bar on the back of that plate. The plate would fit here, and that bar would make up the difference between this and the back of the backing plate. So what I'm going to do, I'm going to take this thing off, turn it around so that this flat surface here is facing out. I hope that'll work. I think it will. I'm going to give that a shot. That way I don't have to machine a matching plate, and that'll be one less part that I have to make. Okay, so now that plate is turned around. It worked out okay so far. Next trick is to try to get that motor mount plate mounted up to it and hope everything lines up okay. A little bit tricky getting those nuts on the screws coming through because that area is so small, but it was okay.
Expecting people anymore. Hear me grieving, lying on the floor. Whether I'm drunk or dead, I really ain't too sure. I'm a blind man. I'm a blind man. When a blind man cries, Lord, you know, there ain't no Saturday, no Saturday. cold month in that room, I found a reason for the things we had to do. I'm a blind man. I'm a blind man. Now my room is cold. When a blind man cries, Lord, you know, he feels it from his soul. From his soul.
I think I've got this thing hooked up now. The motor is in. Treadmill motor is in. That little pulley came in UPS today, so that's good. That's on the shaft. So this motor is driving this. Hope it's centered up enough. Looks like it's pretty well lined up. Best I can tell. From up there to down there, on the camera it looks like it's this way a little bit, but in person it's not. And the belt and the treadmill motor look like everything's all lined up. So those T-bolts worked out pretty well in those T-slots. That's what's holding it to that sheet metal back there. So this is a speed controller. That's what everybody's using now. I've got a couple of them that this will be the third one I'll have used. I've got one on my little Atlas 618 lathe, and I've got one on my bigger Craftsman lathe. That over there, that's the controller for it right up there. And right up above that, that is the little, let me turn that on just for grins. That's what I'm planning to do for the treadmill. This is a tachometer. That thing right there is a tachometer. And inside here, there's a proximity sensor right there, just like what I've got inside the bandsaw. Now, right there on top, you see there's a little magnet glued to the top of the spindle. When the chuck spins around, that magnet passes that proximity sensor, feeds a signal to this tachometer that's inside there. There's a little power supply that's inside there, and that's the display for it. And all of it's self-contained, so when I turn the switch on, of course it kicks the light on above the lathe, it turns on the tachometer, and everybody's happy. And I can turn this thing on to spin the lathe, and the tachometer runs. That's what I'm planning to do for my bandsaw. Let me turn that off. Okay. That's the theory behind that. So I have got this three-way plug plugged into the output of the switch. It's on that side. Turn the saw on. It's running to that device down there. I've got two other plugs. One of them is going to go to that another little tachometer with a power supply in it that I'll build like that one, which I'll set up here. The other one will go to a shop vac, which will put into here. And I'll get a little one that'll fit underneath here. I've got this thing plugged up now. It's plugged into the wall. I am ready to, damn, proximities. Oh, that's my burglar alarm thing going off. I keep walking in front of it. Okay, so I'm going to turn this on. The speed controller's set to 0. I'm going to turn this on and hope this light comes on. Oh, cool. The light came on. Okay, so let's ramp this up slowly till it catches. Come on. Oh, look at that. A little bit of a pull here. I may have a belt that's running a little bit loose. Let's speed this up some. That blade's turning real slow. I like it. Yeah, it looks like that V-belt making some noise there. I might need to put an idler, let's see, on this side. First shot of getting this thing up and going, I have got the motor, oops, and its pulleys under there. That is the J-belt that actually came from the treadmill, on the treadmill motor, and that pulley right there was on the roller. I took it off and made a hub on the inside out of aluminum to be able to mount that roller on, or mount the pulley on. That's a 1/2 inch shaft that goes through there, and that's a 1 inch pulley on that. It goes up to a 8 inch pulley up here. I had thought that was going to be enough speed reduction from that, but I don't think it is. The saw has a single AC outlet right there, which turns on the motor. I put this 3-way on it with this little wall wart that goes up, and it powers this right here. This is a tachometer. On the inside, there's the big wheel. It's 13 inches in diameter, and it has 6 spokes, and I put a magnet on every other one, so there's 3 of them in it. So this tachometer actually reads 3 times as many revolutions as the thing is actually going. The reason I did that is that the wheel being 13 inches, which means it's 13 times pi, which is about 40 inches in length and circumference for every revolution. So that's about almost 36, almost 3 feet, just a smidge over 3 feet. So I figured that by putting 3 magnets on that and speeding the tachometer up 3 times, And what I read on the tachometer is going to pretty closely within 8 to 10% of the actual feet per minute the blade is moving. So, and this right here is that little handy dandy little speed controller for the motor. I've got a shop vac I'm picking up on Monday that I'm going to hook into this other one here. It'll automatically turn on when the switch is turned on. So that comes on and it runs. And that's how many feet per minute, about. And that would work pretty well for that's maxed out. That'll work pretty well for cutting wood. Now to cut steel, according to this blade right here, they want it to be 150 feet per minute. So at 10% under that, I need to set this like 135 feet per minute. There. That right there would be perfect speed for cutting steel. The problem I've got is that's low enough in RPMs on that motor that it just doesn't have the torque to run that blade through anything very quickly. So I'm going to add a second stage of speed reduction. I'll have a choice of two different speeds, a very low speed and then a high speed. This right here will be the high speed. I want to add a second stage of pulleys in it to slow this thing down even more. I think probably about a 3-to-1, and that'll get the RPMs of the motor up into, I think, a good torque band that it'll be able to run the blade at this speed and the motor spinning fast enough that it won't slow down. So that's how that works. And of course the speed sensor right inside there, you can see the LED flicking. This actually runs reasonably well. That rattling is because I've only got 2 volts holding the plate with the pulleys on it to that sheet metal frame on the saw. So that's where I am right now. This is what I've come up with to step down the speed of this thing. Of course, this is the original treadmill motor with JV belts on it. This is where I had it set up on the treadmill before. I added a second stage. This is a 3/4 inch pulley. This is a 5-inch. This is a 1 3/4, just going to use the original belt that was on the treadmill, which is an 8-inch. So I think that's going to step it down pretty nicely. Now my trick is, how am I going to mount that on there? I think what I'm going to do is drill holes in the side of this and run a 1/2-inch threaded rod back and forth across here, suspend the back of the platform on this so it'll tilt up and down this way, and then I'll probably take that piece of sheet metal off right there and suspend it over there on the other end. So this piece of metal right here is what was cut off an aluminum bench. So probably what I'll do is drill holes from here through the centerpiece and through here, run that 1/2-inch shaft through it on this end, where this other end will kind of cantilever up and down. I've got to do some trimming and cutting up there to get this all mounted, but it's sort of in this configuration, and I think that'll work. I've looked at the length of this to fitting underneath the saw. Looks like it'll fit under there okay. This I just used pulleys that I had. This is a 5-inch. It had a 5/8 inch hole in the middle of it, and this is a 3/4 or 1 3/4 inch diameter pulley. It had a 5/8 inch hole. I had 1/2 inch bearings and 1/2 inch steel rod. So I took a lathe and a piece of 3/4 inch brass and turned it, bored it out in the center, and then reamed it to a 1/2 inch. I cut it originally with a 12.5 millimeter drill bit in the lathe, and then reamed it with this 1/2 inch reamer. And boy, that did the trick. That thing fits perfect. Those cast pulleys are not that great. They kind of wobble a little bit. So you can see this one. I put it on the lathe and turned it down a little bit. You can see some shiny spots on it. I didn't do this one, and it actually it has some wobble to it too. I hope that's not too bad once it speeds up, but if it is, I'll probably have to do something like pull that off and put it back on the lathe and true that up somehow. I'm not sure yet, but that's where I am so far. And I do have the speed controller on the side, just like the one that's on the lathe over there. And this is the little tachometer up here that's reading the 13-inch wheel that's in here. So I think today, hopefully, we'll have this thing operational. This is what I finally come up with. I think I've got this thing mounted in there, and it seems to be working okay. What I chose to do was to take a 5/8 inch 11 threaded rod, run it through this end. I made these 2 ears here to fit inside this aluminum channel, and they slide in and out. They have 2 bolts on the side. The channels are slotted on the inside. I don't know if you can see it or not. Yeah, there they are. They're slotted on the inside so that they move. The motor is also mounted where it moves back and forth, so I can tension that primary drive belt. The secondary drive belt is tensioned by those slots and brackets up there. So I haven't turned this thing on yet. I'm getting ready to try it for the first time. Before I fire this thing up, I'm going to go ahead and pull that cover off of it and show the proximity sensors on for the tachometer. Inside here, there's the proximity sensor right there. And every one of these spokes has got a magnet. I'm not sure if you can see it or not. Yeah, there's one right there. There'll be one there. There'll be one right there. And one right there. And when I pass that proximity sensor, they send the signals to the tachometer, which is this guy right here. It counts them. The reason I'm using 3 magnets on this thing is because I'm trying to convert this thing to feet per minute, approximate feet per minute. This wheel is 13 inches across in diameter, which means that each revolution of it, this blade moves about 40 inches. So if I speed the tachometer up 3 times, that would be 3 feet per revolution, 36 inches instead of 40. So I think I can calculate in my head a 10% differential for the speed. So this is the metal cutting blade. It should only run 150 feet per minute. So 10% plus the RPM this reads to get 150 feet per minute. This right here should run at about 135. So if I set the speed, variable speed on 135 that reads on this blade is actually running at 150 feet per minute. So I have not plugged this thing up yet. I'm getting ready to try it. Let me set this over here and give it a shot. Make sure everybody's off. Turn down. Speeds down. Motor up. Black goes to black. Gray goes to white. Okay. So nothing in the way. Speed is turned down. Cool. Light comes on. Let's see. Let's turn the speed controller up slowly. See if it comes on. Oh, cool. That right there would be just about perfect for cutting steel. Everybody's playing. It's actually pretty smooth and quiet. You see the proximity sensor in there blinking every time the magnets go by. I wonder how fast it'll go with this setup. Better step away from that, so. Trying it back down to like 140. I'm gonna try to cut a piece of steel and just see what it acts like. That looks pretty good. Let me turn this off and get a piece of steel, put it on there and see what it cuts like. I had to move everything around so I could put the camera up on my table saw to shoot this. Let's move everybody up. So WD-40. Let's see. Okay. Sounds like it's catching, and it wanted to stop. I think I'm going to pinch it up the belt to take care of that. I think I'm on the road to having this thing done. The only thing I have to do now is get a little shop vac so I can plug it into that. Put the vacuum nozzle into this space right here. And then when I turn it on, it'll suck all the crap out of it, all the swarf. Still, well, this thing was totally gummed up with crap when I opened it up. I cleaned most of it out, but still got a little bit to go. But I'm not unhappy with this little conversion. Just to be sure this thing would work right, I'm using my regular shop vac. I'm not going to use this one on the bandsaw. I think it's just too big. I'll get a smaller one. I'm in the market for one now. But anyway, it's plugged in to that outlet. All three of those are there. Cover's put back on. Everything. I need to cover that thing up. I'll make a plastic cover for that guy. Sure don't want chips and crap falling in it. But let's give it a whirl and see if the vacuum comes on like it's supposed to with the switch. Cool. Looks like that ought to work. I think I'm turning pretty slow. 60 feet per minute. I don't know what I'll tell with that. Oh, one thing I did have to do, I'm trying to remember now. I took some brass. This thing right here is at an angle. This is at a 10-degree angle. I took some brass and cut some double washers. One on each outside each side and one on the inside, so that this shaft right here is not torquing or anything. It's just pulling straight. So probably need a little bit of tune up on it, a little bit of tightening down and adjusting some tensions and whatnot, but I think I'm pretty well done with it now. I hope you heard that. It's pretty noisy in here.